we would like to compute the limit as x approaches 3 of the complex fraction 2 over x minus 5 plus x plus 2 over 5 all over x squared minus 5x plus 6. And as usual, we begin by plugging in x equals 3. And if we do that, we get negative 1 plus 1 in the numerator. And we get 9 minus 15 plus 6 in the denominator. And that's 0 over 0, the indeterminate form. Well, one of the indeterminate forms. So ultimately, since x is approaching 3, we would like to cancel x minus 3. That's what's causing the zeros, because when you plug in 3 for x, x minus 3 is 0. So there's somehow an x minus 3 involved in the numerator and the denominator. The denominator is a little bit easier to deal with. We could just factor that denominator. X minus 3 will be one of the factors, and the other factor, to make the x squared, we need an x, and to make the plus 6, we need a minus 2. Negative 3 times negative 2 is positive 6. So there's our denominator, and you can see the x minus 3. Now the numerator is a little bit trickier. We have to add these fractions. If we have two fractions and we want to add them, then you do so by creating a common denominator by multiplying by 1, and you get AD plus BC over the common denominator of BD. And if you need a helping hand on that, notice the result. AD plus BC comes from multiplying here and adding them together, and BD is multiplying there. So you have a cross multiplication in the numerator and an ordinary multiplication here in the denominator. So let's do this one off to the side. 2 over x minus 5 plus x plus 2 over 5. The BD part is the common denominator. That's 5 times x minus 5. And the AD plus BC, AD is 10, plus BC, BC is x plus 2 times x minus 5. So we have a little bit of work to do here in this numerator. So that numerator will FOIL here, and then after we FOIL, we'll add 10. So it's 10 plus, the FOIL here is x squared minus 5x plus 2x, which is minus 3x, and then minus 10. So we have to do 10 plus that, and we can see immediately that 10 plus negative 10 is 0. And on the bottom we have 5 times x minus 5. And so here the 10's cancel, and we get x squared minus 3x over 5 times x minus 5. So that goes here. So we have a fraction here. The bottom is 5 times x minus 5. And the top is x squared minus 3x. Now let's do one more thing with that. X squared minus 3x is the same as x times x minus 3. So there we can see we've finally unearthed an x minus 3 there in the numerator. X times x minus 3. Okay, so now we still have a complex fraction. We have a fraction here on the top divided by this quantity. And so we will perform now division of fractions, which keep, change, flip. We will keep this numerator just as it is, x times x minus 3 divided by 5 times x minus 5. And then change refers to this fraction bar means division. We will change that into multiplication. And then flip means flip the denominator. Now the denominator doesn't look like a fraction, but technically we could put over 1, and then flipping it means that it will become 1 over x minus 3 times x minus 2. And now we multiply these together, and to multiply fractions, you just multiply straight across. So x times x minus 3 times 1 divided by 5 times x minus 5 times x minus 3 times x minus 2. And finally, we get to the point where we can see that an x minus 3 is going to cancel. We have a factor of x minus 3 in the numerator, and we have a factor of x minus 3 in the denominator, and we can cancel those factors. So we're left with x divided by 5 times x minus 5 times x minus 2. And the final answer will now be obtained by plugging in x equals 3, and if possible, simplifying the resulting fraction. It's going to be 3 divided by 5 times 3 minus 5 is negative 2 times 3 minus 2 is 1. So it looks like we have 3 divided by negative 10, which is the same as negative 3/10. The negative can be put in front of the fraction. So 3/10 with a negative. Negative 3/10. Final answer.